So in this project, I'm going to present my final artifact, which is a RAG-based AI chatbot system to retrieve information from set of documents. So it is a project that I'm working under human supervision. It is an industrial project. So let me just walk through to the application that we are working on. So this is a project management software, and it has multiple capabilities. The one I am working on is the user guide system. So as you can see, the queue that I've already given, like how we can, but let me just give you again, like what is right. If we give the query in the chatbot system in the front end, so it retrieve information from the set of documents that we have given in within our database. So what this the whole project purpose is like, so it has like different use cases. So if you are a project manager and you are dealing with multiple projects at the same time, so you don't know every information, you don't know every information from each project. So this project is going to help you. uh it's going to help you to find specific information from the specific project. So instead of going within the project, you just give the information and it can retrieve the information for you. And for now it is getting the basic information. Obviously that's something that the company is going to work in the future to give more personalized information, diving deep into their each projects and like more into the software. So for now we are retrieving information, and what we have automated in the user guide system is the help system. So as you can see, like for now, if you are a new user, as a project manager or as a customer or any other stage, so you have to get yourself familiar with the whole help system. So with this system, like you can get most of the information about what all those tabs are, what they are doing, and how we can implement these things within our project with our project management, and how we can like do things more efficiently and more quickly instead of just looking information everywhere. We just give the query within our chat and we can get the information, and from there we can get the idea like how we gonna implement that thing within our project. So like I said that we have implemented a RAG model. So how, let me just walk through the RAG model, how this RAG model is working and how we are going to get that. So first of all, like I said, like we got all the documents, like as you can see, like in the user guide section, we have these 8 documents, 9 documents. So if you can see, like this each document is from each screen of the software. So we try to automate the information from each screen so that user can get more information from the chat. Like we are trying to get it more personalized. So how this red mall is working. So first of all, we like create the PDFs, and we go to visit our working directly, and from there we can start our process. So one thing that I would like to mention that currently our system is capable of handling not only PDF but also the Word documents in other formats too. So diving back to the RAG model, like how we have implemented this, let me just give you a general description of how this thing is working. So if all the documents that are loaded in our working directory, those are like separated, are scanned and separated into a sizable chunks, and those sizable chunks are then embedded and then they are put into our vector base. So that's where we store all our embedded information retrieved from the PDFs that we put in the working directory. So that's the first step we can see. So the second step is if a user give any query, so that query is also embedded and then it is matched with the most closest number from the ChromaDB, and it retrieves information based on the word similarity for now. Yeah, the based on the word similarity, and it gives you the information back into your chatbot. So that's how this thing is working. So As I said, like these are the document that these are documents from each screen of the software. So let me just dive deep into how this thing is working. So like you said, like that's the main file that we have coded for most of our things. So as you can see, first of all, we are using ChatGPT for now. In my project, I have researched on the DeepSeek, but since the company was doing already on the ChatGPT, so they were kind of fixated to that thing, and, and mostly because of the security reasons, they are not willing to change from ChatGPT for now. So that's the restriction that we have to use the ChatGPT. So also for the like the, we are using ChatGPT as an LLM. So as you can see, the initialization of how the initialize how the project is starting is all the documents that we gave within our working directory that are loaded first, and then all those loaded documents then go to our Chroma DB. So here you can see like we give the input query to input query, and that input query is like the process, and then as you can see like within the in this system like how our front end is interacting with our backend, and how we are parsing the information from the documents within parsing information and then embedding the information to put within our Chroma DB. So as you can see, this is how we are trying to set up our chat system, and this is the query system, like if we give a query within a document and how we are gonna answer that thing. So let me just give you a brief walkthrough like the endpoints that we have of our chatbot, like how we are interacting with our LLM and how our front end is interacting with the backend. So as you can see, like we are using the fast API. So like these are the local hosts that we are currently using for on our end for testing and for other things too. So as you can see, like we are using ChatGPT, and you can see like the we have set our response time, that is 100, and as you can see like we have set the endpoints of our LLM to communicate with. So as you can see, the first endpoint is like the document. So if the documents are not loaded in the in our system, so there what the system do is it's gonna scan all the documents and see if there is any new document or any change within a document, and instead of just going through all the information, all the documents again and again to store and embed the information, since it is not very efficient. So we are gonna what we're gonna do is like we, we're gonna track the changes within the documents and then track the new documents that we're gonna put in our software, and from there like we can get the idea like what new widgets are, and we can like embed the new information within our tech database. So as you can see like as that working, so this endpoint is for the chat, like if we give any query in the chat, so how gonna like communicate with our project from the front end side. So like if we give any query, it's gonna track that thing, and like and that the thing that happened on it. And that's the like to get the information. So that's the second endpoint that we are getting, like what the response time is, and like these are different parameters of like to know about the information that we are giving from our backend. So these are like key parameters of that we are keeping in check of like what type of answer, what's mm, the the response time, and like the tokens that our model is currently using to give the answer. So like I said, so that's the thing that we are currently like that's the endpoint that we are currently like we have to check the performance of our of our project. So now we're gonna read that's the main file. You can see that the whole main coding is working, like how the backend each step is working. So first thing first, so since we are using the ChatGPT, so we have to give the key folder, that also since we are using that, so we have implemented a LangChain. So like we need the key for ChatGPT and LangChain. So the first thing first is like we're gonna give to the we're gonna give the key to that. So in this part, as you can see, like we have used two models. So how we are using, since it is very, as you can see, the company is spending money on how our RAG system is working. So if we use a more expensive one, so obviously if we are using GPT-4o, at all time we have to spend more in cost of money. So in this project, like I have implemented two models. So if we give a very simple query, so you don't have to use GPT-4o model for that. If it's very simple query, so you can just quickly get the information from 3.5 turbo, since it is more faster and accurate for small size queries, and like we can get the information from that. And if the query is more complex, then we can jump into the premium model, the 4o model, and that gonna like change the scenario, like how we gonna deal with the complex queries. So as you can see, this is the premium model we are using. So the second thing is like how our model is getting the information. So as you can see, like we have fixed the what is this key thing, the core thing is like how much number of documents or how much number of the the embedded vectors that we have saved within our database we are retrieving from there to get the information. So like you can see, like I have set a range of values from there, and as you can see, the maximum number of tokens for the embedding that I have set is like in 950. So supposedly I have divided that 950 within an overlapping. So for 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 starters, it's gonna take 800 tokens. Uh, so, so let me just get it clear. This token thing that we are currently discussing, this is about the information that we are retrieving from the PDF, and we are saving that PDF within a token size in that in our Chroma DB. So as you can see, like I have set the limit of 950. If for starter it's like it's 800, but I have a given overlap of 150. For example, like if we don't get the whole context of each embeddings that we save in our Chroma build, so if it's not like making sense, it made more than 800 tokens. So I have set a limit of like if they are two queries, so it can like retrieve more 150 tokens from the second the second um, the vector, the embedded that we have saved to complete the meaning of to complete the semantic meaning of the query of the embedded that we have saved. So here's the thing. So if you can see here, I have like fixed the document, like since we are using a PDF. So I just here you can see, yes. So here I have just categorized the documents we are, since all not all documents are of same size and same number of words, non same number of pages. So I have categorized the documents within like three different categories, like of short, medium, or long, based on the number of words that each PDF consists. So if a PDF is less than 1500, so it will be a short. So if a PDF document is 300, 3000, it's going to be medium, and if it's over 3000, it's going to be long. So here jumps our also here jumps our the LLMs that we are using. So if it's not that, so if like we have um, an a longer document, so our the library that we use like the PyPDF is gonna scan and like it, since like we are using three different categories, so it's gonna like more time for the longer one, so it's gonna like create a more efficient way to deal with that thing. And also I have used some regex commands here to retrieve information more efficiently and skipping the irrelevant things from the PDFs and like only get the more crux of the documents that we really need in our system. So as you can see, like we are using the summarization text here, and also like as we have used in my sense, I have used the BART model for the summarization. So for the summarization, I have set a limit of like 150, maximum limit of 150, and the minimum limit of 50. So as you can see, like since mm, we are spending on the token, so that's something that's more efficient to also handle the token thing too within our thinking. But then I have removed this summarization thing from now, like since we are using BART model and the company is not using the distributed system, so it takes around 45 to 50 minutes to just load the documents and summarize the documents and embed the document within our ChromaDB. So at the time of testing, the company said like they are not willing to spend that much time. Since like if we have like minor changes, so they're gonna have to restart again, and obviously it's gonna cost them to spend more time in terms of like running this project from scratch. So I have also removed that thing, but like as you can see, I have the set the limits for that and then did some work on the automation thing. So here you can see also what I have done is like I have like I said, like I've made categorize the documents based on the number of like the characters that we currently have, and then simply to get the more crux information instead of getting the headings and some unknown, some not the unneeded information that we don't use within our thing. So as you can see, so in this process you can see that this is the section we are preserving the structure of the information within the structure of information that we are gonna give to our backend to store within our database. So as you can see, the chunk size, the font folder, and the thing, and so the same thing that overlap, and then we can calculate the chunks. Like I said, like I've removed that for now. So I have just given a brief view like how this like summarization thing is working. Like I have set the limit size not only for token but only for also for the characters, so that we get a more semantic summarization of the whole whole chunk of information that we are scanning out from the PDF and that we are going to store within our database. So the summarization part is like before the storing of information in our database. So the main thing is either loading of documents. As you can see, like in our case, we are using the Python library PyNUPDF to scan the documents and load the documents within our Chroma database. So that's just the user writing. We are just telling the folder that we currently have to store all the PDFs that we are currently using. So also for embedding, since the embedding is like giving each vector of information the certain series of number to categorize it when we are retrieving the information. So I think it's much more efficient to match the number instead of matching words to word from each vector. So that's what we are doing in our case. So we are using text embedding tree small model for embedding technique as an embedding technique. So the second thing is like once we have load the document and we create a vector store. Like I said that we are using a vector tree, the text embedding tree small model for embedding, and after the embedding we are storing information within our Chroma database. So as you can see here we have stored all the information that we get from the PDF. And yep, and you can see like is just retrieve just like optimizing the process of retrieval, not the optimizing process of embedding to our into our cover base. So the next thing is to how to get the embedding. And also we implemented the cache system. So how this cache system is working there's the so instead of doing things again and again, it creates a temporary memory for each session, to remember a certain most frequently used number of documents or number of the embedded information that we store into our database. So like I said, like if we currently don't have a ChromaDB like market, like I have run the whole project, so I already have the database. But if we don't have, we create a database from the start. Like this, it's gonna make the batch of information and show the batch of information in our database. So it's just like telling information how the batch system is working. And like I said, like this is information on how our vector DB is gonna be created and how it's gonna be storing the information. So this update document, like I said, that we have implemented a technique where if we if we put a new document or we change information within a document, so it's gonna scan and just put the updated information rather than just getting recreating the database each time. So obviously we're gonna save processing time. So as you can see, it's gonna go through the whole process of chunking, and here is the retrieval. So uh, like we see how the retrieval is working is like we have set the number of documents, like how much the documents are gonna be retrieved when we give a query into our front end, and how we are gonna receive the information. So also we have implemented a fallback retrieval. So if within our certain time, like we have set a time, like if like a certain time the inform information is not retrieved from the embedding, so it's gonna fall back to the PDF and find information from there. And based on that, we're gonna find the most closest information based on most words match from the query, and in that embedding, and then give us the information from there. So that's the thing, and that's the query complexity. So what we have to do is that, like previously the the project was using a certain number of documents for every query, and we are not able to ask the complex question from our system. So here what I have done is like I have categorized our the queries into like four different categories, and I have set the information like if a query length size is less than 20, it's gonna be small. Is like is greater than 20 and less than 100 is gonna be small. And what types of question we are expecting to see in our the like the the most simpler one. So these are the number of, these are the like type of questions that we are expecting within our that, and I have like tell the complexity of the like complexity one. Similarly, for more complex, I have given like the maximum uh, number and types of questions that we can ask, and I've categorized the information based on the complexity. So if a question is simpler, so like I said, like we have implemented two models. In that case, it's gonna jump. So if query is simple, so our model is gonna use the 3.5. But if it's complex, so since it will be needing more documents, so using a base model of 3.5 is not gonna be more efficient, so we need a more stronger model for that. So in our case, the 4 is gonna jump and retrieve the information from there. So as we can see here, I have categorized the whole 4 categories based on the complexity that I have set, and the word limit, and the types of question that we're expecting within each category. So yeah, as you can see, like if complexity is like 2, it's gonna be simple and medium and complex and then very complex. So as we can see, we are initiating our the chat model service after loading the document with, like I said, the token size of 1000, and with the for a premium model it's gonna use 800. So like we got like we're gonna like the conversation buffer memory. So what conversation buffer memory is storing the information, uh, storing information about the documents. So it's gonna help model to get more context aware information to give the to return the answer to the user in the interface. So this is what is doing, like doing the documents, and based on the complexity of the question, if it's not gonna be able within each category, it's gonna fall back to a simple mechanism where it's gonna look again for the information based on the similarity. Even though in that in for category, it is also implementing the word technique, the word similarity thing. But in the fallback mechanism, it's also implementing the same technique. But like if we don't get the answer from those 4 specific types of the questions, it's gonna jump back to the other one. So as you can see, loading documents, updating the documents, and then it's gonna uh, update the document, like, and then like determine the documents count, and then showing the information. As you can see, if you like, can see the is already like if you're giving the like similar kind of queries in the chat, so the cache system that we have done is gonna store as a like uh, the previous chat, and instead of just processing it again and again for getting the information from the retriever, it's gonna take the information saved within our cache and just give you immediate answer. So it's gonna save time and give the more speedy response. So as you can see, the it's more like about the retriever, how we're gonna retrieve the information there, and like I have said the model that we have, the LLM model, and here we have, and then a document thing, and how that like the the fallback system will be working. So this is the system prompt that we have given in our case. So like we have told them that, and what as an assistant, what and how you should be looking for the information, how you should answer the user based on the query. So we have the use assistant query where we have briefed all the basic scenario of how it should work. So after that, like if the it is like how you should answer the question. And you see the this is the relevance, like I said, like we have implemented The embedding that is working is based on the word similarity, the most closest match based on the query and the retriever. And here like how we are gonna answer and how the prompt that we have given, the system prompt that we given, how it's gonna affect the answer before it's gonna give the answer to us in the front end. So this is like to calculate the time and the tokens, the number of tokens that we are using to see like if our system is like efficient. And so as you can see, extracting the relevant information, splitting the information to give it a more presentable thing, with more presentable, like in more context, in more, I would say like semantically aware about the information. So like this is getting all the information, and as you can see, this is like different parameter that we have set about the retrieving information and the setting the information, and that's how the the document and the basic RAG system is gonna be working. So I think that yeah, I have like covered the endpoints and in the backend and the backend thing. Since I have not given access on the front end directly, so that's something that was done by the software engineer of the company. So that's all about my project, and that's about the implementation that I have done in my part. Thank you.